Okay, today we're dealing with materials handling, particularly for a construction site, like some of the materials that you see here. Objectives, well, we'll be dealing with lifting procedures, and we'll be dealing with the guidelines for stacking and storing materials, and for non-motorized materials handling equipment, and for motorized materials handling equipment. And then we'll focus on rigging skills. There is specific training that you get in order to be able to connect a load up onto a crane with slings and shackles, and there's and for picking up with other kinds of equipment also. That's all called rigging, so we'll deal with a little bit of that. So the first thing is, with materials handling, you have to assess the task and any potential hazards. Make sure the load isn't too heavy, too hard to grasp. Watch for protruding nails, wires, or sharp edges. That's important. And then, if you're going to have trouble, if it seems like it's going to be difficult by yourself, you ask a coworker for assistance. So the first thing is you have to inspect your path and make sure that you've got a safe path for carrying your load across the yard or across the space. Read warning labels and make sure you're wearing the proper clothing. Loose-fitting clothing gets caught on things, rotating shafts, but even on the load itself. And you want to make sure you're wearing the right personal protective equipment, PPE. Wear gloves and avoid wearing jewelry, rings, earrings. Be careful that your hair is not loose and that sort of thing. So in proper lifting, you got to always make sure that you're lifting with your legs, not your back. Keep the load close to your body. Be careful about twisting and turning. You're better off to pivot with your feet and your body when you can. And when unloading materials, make sure that your leg muscles are used to set down the load instead of trying to bend down again going the other way. Space your feet far enough apart for good balance and control. And move your fingers out of the way as you set a load down. So there's a fair amount of common sense in this stuff because we do this kind of thing every day in various ways. But you should be asking a coworker for assistance when the load is heavier than 50 pounds, or if the load is longer than 10 feet, or if you're dealing even with light loads like a sheet of plywood in a wind gust or a tarp or something. Wind can be a problem, so you ask for help. There's no shame in asking for help. Never carry more pieces than you can control, even when they are light. Sometimes control is the main factor. When you are handling long loads such as scaffolding poles or long planks, be aware that objects and persons may be struck if you're not careful about how you're rotating them around through the field. And never pass any material to another worker unless that person looks directly at you and expects to receive it. When you're reaching and lowering heavy loads from overhead, it can be dangerous. Sometimes in the middle of picking up and lowering the load, you discover that it's too late to put the thing down again because it's too heavy. So anytime you're reaching above shoulder height, that can cause stress on the shoulders and back and give you trouble. Before you attempt to lower overhead loads, size up the load. If it looks too heavy to have been lifted by one person to get it up there, it's probably too heavy for one person to take it down. Now, some of the ways you figure this out is by asking yourself, how did it get up there? Was it put up there by a lift truck, a forklift, or by more than one person? The way it got up there is probably the best way to get it down. If you must place a load to one side as you're putting a load down, move your feet instead of twisting your body. Now remember, in construction, the basic rule of fall protection is 6 feet. You must be protected from falling more than 6 feet. So use a safety harness or a positioning belt with a lanyard when you're working from a height of 6 feet or more. Never throw tools or materials up to a worker on a higher level or down to a worker on a lower level. Instead, you should use a rope to raise or lower tools and materials to and from the elevated work area. And once the material has been lifted to the elevated level, tie off the rope and secure it to keep it from falling. Never carry tools or materials by hand up a ladder, or throw the material up to or down from a work platform. And then just above that, I should have pointed out that always keep your hands free when you're climbing a ladder. You got to maintain 3-point contact. That means 2 feet and 1 hand, or 2 hands and 1 foot. But you've got to keep that contact. And that basically means you cannot be carrying anything when you're climbing a ladder. Place loose objects, smaller objects, in a bolt bag, a special bolt bag that's designed for this purpose. Way safer than using a Home Depot bucket or throwing the parts to somebody to catch. Never stack or store materials on scaffolding either, because that's where you're walking, and so you're creating all these tripping hazards and things that you could kick and launch off the scaffolding. With cables, working with cables, well, electricians run conduit, and when they start fishing wires into the conduit, they end up having to take cable or fish tape, some version of that, and push that through and then pull the wires through. And so you got to make sure you're only using a low stretch rope or cable for doing the pulling. And part of that is that if any component fails, the stored energy could slingshot like a rubber band and injure you or someone else. So it's best also to keep when you're doing the pull, to keep the rope confined within the conduit wherever possible. So when you're stacking boxes, you've got to keep the aisles and passageways clear in the storage area. Never stack cartons higher than the height listed on the carton. Somebody's thought that through for you. And then there's some other rules we can use. Never higher than a 4-to-1 ratio of the narrowest width on the base of the box to the height. Should be no higher than 4 times that dimension. So if you got a 2-foot wide box, you can only stack those up 8 feet high. Stack lumber on levels, solidly supported sills, and remember to remove all nails. And stack pipe neatly and chalk them so that they cannot roll away. So, look at this lumber pile. That's one heck of a pile here. There's nails sticking out. It's all random. It'd be difficult just to sort this pile out even. But because there's all kinds of nails in there that could snag you. So you got to stack pipes and fittings according to size so you keep them orderly, and it's the same thing with lumber. Failing to store materials properly can lead to accidents and injuries and such, and certainly a lot of wasted time. So remember to remove all nails from reusable lumber to prevent accidental injuries, snags and such. You can get fairly serious injuries from hooking a nail in your wrist or in your leg or something. When you're dealing with cylindrical storage of pipe and such, like we see on this upper left-hand picture, you should be blocking and chalking them so that they can't roll away. And when you're dealing with stacks of bags of something like bags of concrete and such, like you see on this pallet up on the right-hand corner, you want to make sure that you're stacking them properly. That means rotating the pattern every level. So here they've got a pattern of how they stack the bags on level 1, and level 2 is rotated basically 90 degrees, and they start at the same pattern going a different direction. So we call that, what you see down here in the bottom bullet, second line in the bottom bullet, you're stepping back the layers, but you're cross-keying. So we call this cross-keying, as you rotate these patterns about 90 degrees, reversing the orientation of the bags. The minimum standard is at least every 10 bags, but that's really a pretty weak minimum standard. Really, every single level. There's no reason why you can't rotate and cross-key every single level, and that's what you normally do in stacking bags of concrete and many other things. And then when we're stacking brick or block, we do the same thing. We rotate the pattern around in a way where it looks like a brick wall. And it's a kind of a similar thing with concrete blocks. So here's the thing with a stack of brick is that when it's on a pallet, you can stack it up 4 feet high maximum as a flat top, And then beyond that, you can build a cute little pyramid on top where you step back a half a brick each level as you go up to a maximum of 7 feet. Well, what you need to remember is basically 4 feet high, and then you can taper back. If you can remember that, that's all you need. 4 foot high stack, because first of all, most of the stacks, nobody's going to make that cute little pyramid on top. Nobody wants to waste that kind of time. It takes a lot of time to go and stack all that brick. So generally there are 4 foot high piles for brick, flat top, and for masonry block, which are larger. Standard blocks are normally 8 by 8 by 16 inch blocks. Then you can go up to 6 feet high, and then you start tapering back a half a block each level after that. So remember the 4 foot high for brick, 6 foot high for masonry block, and then you start tapering. And you'll be fine. Okay, so non-motorized materials handling equipment. Examples of these non-motorized or manual materials handling equipment include things like material carts, hand trucks, roller skids, wheelbarrows, pipe mules, and then a larger version of a pipe mule would be the pipe transport. And then there's a jack of various kinds, and then a pallet jack, which is not much like a jack. It still jacks up, but it's really more like a manual forklift. These are all examples of non-motorized manual materials handling equipment. And in every case, for equipment in general of any kind, you inspect it before using it. So always put the heaviest load on the bottom of the device to lower the center of gravity and to make it easier to handle. It makes everything safer. If you're stacking boxes, it's kind of like the cross keying. You stagger the boxes as you stack them in order to make the stack of boxes more stable. Plan your route as you move across with your non-motorized materials handling equipment, such as a dolly or a cart, by making sure you've got the smoothest path with the least amount of hazards involved. Plan that out before you ever get started. Maintain a safe speed and keep the device under control. Keep your hands and feet from underneath the work-saving device, this non-motorized materials handling device. And try not to stack items higher than you can see. Any higher than your line of sight, and you've got a blind spot. So if you have to haul things and roll something with the over top of your line of sight, you should use a spotter to ensure the path is clear. Materials carts. There are 4 wheels at least, sometimes 6. You've seen these at Home Depot and such. These carts are meant to transport materials across the job site. Before using carts with casters, you should inspect the casters or inspect them overall. When using a cart with pneumatic tires, you better check the tire pressure. Pneumatics, when we're talking about pneumatics, we're talking about air pressure. That's just another name for it. So check the air pressure on the tires. Okay, so let's see. The other thing about materials carts, you look down here at the second from the bottom bullet, it says use caution when moving a cart on an inclined or declined surface, a slope, and never load a cart beyond its labeled weight capacity. So that capacity should be listed somewhere on the side of the cart. Here's the thing, if you overload the cart, you will lose control on an inclined or declined surface, and it gets very dangerous. Hand trucks. We've all seen hand trucks. They always have a rated capacity on them. Before using a hand truck, you should inspect the framework for stress fractures, and check the tire pressure. If they're pneumatic tires, if they're air pressure tires, if they're solid tires, you still should make sure that they're all stable and well attached. When loading a hand truck, you tilt the object to slide the cart underneath, and then you hold the object against the cart as you tilt both back on the wheels. Some of these things are just common sense if you've used these things, but it's important to kind of state them out loud. With roller skids, they're kind of like little carts that you might use several of them underneath a heavy load. And so typically 2 to 4 of these roller skids put maybe under the 4 corners, one in each corner, and they have rollers underneath, and so then you can push the heavy load along the way on a path. A lot of times it's up on a roller table, but it could be on the ground. These often have handles like you see in this picture that can connect up with the roller skids so that you can push or pull them. So here's what they look like without a cartoon involved. And so I think the red one's definitely nylon. I can't tell with the yellow one. It might be steel rollers, which can take a lot more weight. Wheelbarrow. Well, this one's a two-wheel wheelbarrow, but many of them are single wheels. Most of the quality ones that you'd use on a construction site will have air pressure, pneumatic tires. So check the air pressure. Use proper lifting techniques when using a wheelbarrow. That means keeping your head up so that you can see where you're going. Keep your back straight and bend your knees to lift with your legs, to lift those two handles up with the load. A pipe mule is kind of like a wheelbarrow, but it's meant for pipe. It's got two wheels with kind of a U or a V shape where you can stack the load of pipe that you're going to take. It can be used by one person. But generally you have to balance the pipe on this cart, and then you've got a handle that you can kind of balance if you've got the load balanced well enough, and you can kind of roll it along like a wheelbarrow. So you place the wheels of the pipe mule underneath the center of the load. You have to balance it. Whereas this device, this yellow device here, is a pipe transport, which is a large, heavy-duty pipe mule meant for longer, heavier pipe. And the way you load this one is different. You basically, from underneath, you ride over top, and then you take the chain and hoist the pipe up underneath and tie it to the bottom. It's generally supposed to be used by two people. So a jack, like this bottle jack here, is a portable device used for raising heavy objects by means of force applied with a lever, a screw, or a hydraulic press. Well, this is a hydraulic jack, so you'd have a handle you'd stick in that little slot to the right-hand side to pump it up, to raise it, after you've tightened the little valve down at the bottom. But there are lever jacks, there's screw jacks. Some of the screw jacks are screws by a rotating thing around the whole middle section, and there's some that are more like scissor jacks. There's so many different kinds of jacks. Before you're using any kind of a jack, you should inspect it to make sure there's no flaws, any damage. If it's hydraulic, you're looking for oil leaks, because hydraulic fluid could be leaking out of it, and then that would reduce its ability to lift very far. Check the area prior to jacking the load to ensure everything's going to be clear of obstacles. Position the jack so that the load is centered over top of the jack. When using more than one jack, ensure that they are all matched and positioned so that the weight is uniformly distributed to avoid unexpected load shifts. Now, all jacks should be lowered together at the same rate, or upward, raised or lowered, either way, at the same rate. So you have to be careful and very systematic about how you do this, very methodical. Before jacking a load, make sure that the base of the jack is placed on a solid, even, and level surface. Never place the base of the jack on bare soil or on any other surface that could possibly compact or shift under the load. You really need to build a proper base for this thing, often out of heavy timber. But it could be on a concrete slab if the slab is sound and strong. If there's a possibility that the load could move while jacking, make sure that it is chalked. So that's particularly true of cars. You know, you jack up a car, it could roll away on you, so you've got to chalk it up to restrain it in some way. But it can happen with other equipment or other things that you're lifting. Never stand under or place any part of your body under the load of a lifted jack, and never operate a jack while another worker is standing under or laying under any part body under the load. So that comes down to this basic slogan that's used all the time in safety dealing with jacks. This last bullet, it says, never support a load with a jack. That word support means that you've got the load safely in some position. You're counting on that load to stay there so that you can climb underneath it. So support has special meaning here. Never support a load with a jack. You can lift the load with a jack, and then you block up the load with cribbing or position stands. So the cribbing would be dunnage or cribbing or heavy timber or something of that sort, that you're something foolproof. One thing that's not foolproof would be a masonry block. You don't use masonry blocks. Concrete masonry blocks have no reinforcing. They can shatter like glass when you least expect it. Never trust your life to a loose masonry block. Never step on the jack handle to get additional force to leverage to pump that jack or whatever. That means also that you never use a jack handle with extensions or a cheater bar on it. That means you're overloading the jack. Always check the jack's maximum rated capacity and make sure that the load you're picking up is less than that load, less than the maximum load of the jack. So the jack's rated capacity has to meet or exceed the load that you're picking up. And it's really better if it exceeds it well over. Okay, well, let's see. If not, then you get a bigger jack. Let's see. Sometimes when a jack, when making a jack lift, you might use a hydraulic ram, sometimes referred to by a brand name by Porta-Power. That's one brand name, but basically hydraulic rams or hydraulic jacks have electric motors typically, most of the time, that power a hydraulic pump so that you don't have to run a lever on a jack, you know. And so they require inspection, looking for leaking fluid and such. No matter what, never leave a jack under a load without blocking it first. So you don't just jack up your car and walk away. You've got to put the position stands in there, or put some heavy timber in there to keep it from tripping over, even when you're not into there, because you don't know who else, when you leave the jack alone, might try to climb under there that doesn't understand the situation. Pallet jacks, well, they do jack up a lot of times with hydraulics, like very much like other jacks, but they're really more of a forklift substitute in manual form that you can roll inside of a pallet to lift up a pallet to move it around the shop or the yard. So yeah, you inspect the pallet jack before using it, but you also, looking for oil leaks also, but you also inspect the pallet to make sure it's structurally sound too before you try to lift it. Now we're moving to motorized materials handling equipment. Often and typically powered by gasoline or electric motors, battery powered mostly. You must be trained, certified, and authorized. This is kind of a slogan or a mantra that's said and spoken many times in occupational safety. You've got to be trained. That means you've had some training on how to use that equipment. And then the certification, being certified, means you've got a card or a certificate that proves that you've been trained. And then your company has to have authorized you to use or operate that equipment. You need all three: trained, certified, and authorized. There's many things like that in safety that come back to those three words. When lifting materials mechanically, even with a motorized materials handling equipment, you should secure the material. First, make sure it can't fall off. Be aware of any obstructions, such as people or equipment that are in the path, in the same way as we thought of and discussed with the non-motorized equipment. Look at the two boldface things down here. They're very much related. Know the weight of the object to be handled. You need to know that weight that you're going to pick up. And then know the capacity of the handling device. You got to know the rated capacity and never exceed it. Ensure all the handling equipment is in good working order, free of damage. Common motorized materials handling equipment include things like powered wheelbarrows, powered concrete mules, industrial forklifts, and rough terrain forklifts, and freight elevators even. So a powered wheelbarrow, also known as a power buggy, is similar to a manual wheelbarrow, but except it's powered. Now this particular one is one that you walk along as you move the load, whereas some do have a ride-along platform. But you should always inspect the machine. That's true for any kind of equipment, but it's particularly true when there's a powered piece of equipment like this. There's additional hazards that you can lose control of this thing. Avoid the pinch points on dumping mechanisms and from pivoting around. You don't want to bark up your hands on those handlebars as you're moving around through the job site. Be sure the dump bucket is always securely down when you're not dumping, so it's got to be locked down. do not move the buggy with the bucket in the dumping up position where it's tilted forward. Do not mount or dismount the buggy while it's moving, so you don't climb on or off of it. Well, here there's no place to really climb on, really. Not really on this thing, but some of them do have a platform for the operator. It's only for the operator. Here we're looking at, no riders allowed. Do not exceed the load limits. Now this next one here is a concrete mule. It's similar to the powered buggy, but it's designed specifically for concrete, the shape of the bucket and everything else. And it's basically like a little miniature dump truck, and that you can ride on the back, kind of like you would on some of these modern commercial lawnmowers. They have a platform on many of those. So it's often called a Georgia buggy, and it's where it's meant and designed specifically for filling up with concrete and riding it over to a place where you dump the concrete in. One thing you have to watch out for here is that when you go to dump the concrete, you could roll right into the hole if you're not careful. So what we normally would do, and what you should do, is to use a tire stop, a board of some kind that's positioned specifically that you can bump up against to keep you from accidentally rolling in or driving into the hole, into the form, and that sort of thing as you get ready. You need a kind of a speed bump or a parking bump. So we call it a tire stop board or a chock, wheel chocks, to prevent the mule from rolling forward into the pit during the emptying process. When operating the concrete mule, this thing is self-propelled. You're standing on that back platform. Ensure that there are no obstacles or other workers in the turning radius of the rear platform as you are backing it up, and always look behind you when you back up before you could run over somebody or something. No passengers allowed. So now we're looking at the lowly forklift. We call it an industrial forklift in this case, but it's larger than some. There's much smaller forklifts than this one, and there's many more that are similar design but much bigger. OSHA classifies forklifts as part of a group of pieces of equipment called powered industrial trucks. When you go to look up OSHA standards on forklifts, you'll often find them refer to them as part of the powered industrial truck family. So yes, they've got fixed wheels on the front where the load is at with this design of a forklift. And then the back wheels behind the driver are the turning wheels. So it's kind of like they've taken the controls and everything and turned it around backwards compared to your car. This one's propane powered, which makes them safer inside of buildings. So they can typically take heavy loads on areas with smooth terrain. They can get stuck so easily. So, it's okay on this rough concrete here, but they wouldn't work out too well on a rough, muddy terrain. So ensure all workers maintain a safe distance from a forklift. This perimeter's distance is known as the work zone of the forklift, an area where the machine may come in contact with objects or people either with the rear end or the front forks. So then the other thing is the workers need to also stay clear of the fall zone. We call the fall zone the area that's twice the diameter of the height of the object being lifted. So if you've lifted an object up 10 feet in the air, then you need to stay 20 feet back. If you lift the load 15 feet in the air, you need to stand 30 feet back. So as the load goes higher and higher, you should be backing away from this thing. You should make eye contact with the operator, the forklift operator, so that he or she can see you and recognize and acknowledge you. So that also means avoid the driver's blind spot where they can't see you, because you never know where they might be deciding to zip around and back up quickly in between dropping a load and picking up another one. The most common accident with a forklift is running over a pedestrian. So it's a very common issue. Be aware that the forks pivot on the front wheels, as I was kind of mentioning here, and turn. The whole thing turns with the back wheels, which could cause a potential pinch point. And so you always have to be thinking when you're around heavy equipment or a heavy load suspended by a crane or the forklift or any other kind of a piece of equipment, plan your escape route. What am I going to do now, and where am I going if this happens? So you have to think your route openly and ongoing, so that you always have some place to run to. Because when something happens, you won't have time to think. You already have to be ready to run. And better to stay double the height of whatever's there back from that. And while I'm thinking about a crane, keep away from being underneath the boom at all. You know, the load could be one place and the crane, you could be between the load and the crane underneath the boom, and that's a bad place to be also. But here we're looking at an old-fashioned freight elevator where you pull the door up and the other door from up above down, and they meet at the middle, and that becomes a pinch point. So NCCR likes to talk about these old freight elevators. I don't see them too often, but I guess they still exist in lots of places. But typically when a freight elevator door closes, they travel from, in this case, from the top and the bottom, simultaneously presenting a pinch point right where your hands are at in the middle. Check the weight capacity, the rated capacity of the elevator, and make sure you don't exceed it. Now we're finally getting to rigging safety. When you're dealing with cranes or picking up loads with other kinds of equipment, even a track hoe or a forklift or many other kinds of equipment are sometimes used, and that's allowed. But always when you're picking up loads, you have to determine the weight of the load you're going to lift. You need to know how much that thing weighs that you're going to pick up. And then you need to know, and there's ways of finding that information out. And from site management, somebody should know, and if they don't know, you can do the research. You can contact them. If you're picking up a piece of equipment, you can contact the supplier of that equipment and get the load weight. You need to know what the load weighs before you dare pick it up. Now, if it's materials, you can estimate the materials by all kinds of ways, but the most common way is if you know the volume of the material, and you can look up online and find its density. And if you know how much it weighs per cubic foot, and you know how many cubic feet you have, you just multiply the two numbers together. You have to know the safe working load of the equipment you're using, the crane, the forklift, and the rigging hardware, the slings, the shackles, the hooks that you're using. So the safe working load, we abbreviate that sometimes as SWL, or sometimes we say swell. But the SWL also has other names. You can call it the rated capacity, the lifting capacity, the working capacity, the working load limit, or WLL. So there's a number of names that all mean the same thing here. Recognize that there are factors that reduce the equipment capacity. So, for instance, if the crane or other equipment, but particularly a crane, is not very level, that can reduce the crane's rated capacity. So you're supposed to keep the crane within 1% of being perfectly level. That's 1 inch in 100 inches, so it's not that extreme, but it's enough that you need to check it out. And if there's wind involved, that reduces the crane's rated capacity too. And then, of course, the capacity dramatically changes when you're picking up something right up close to the cab of the crane. That's where its maximum rated capacity is, compared to out some distance. As you get further and further out from the crane, the capacity of that crane dramatically drops. So every crane has a load chart within the cab that the crane operator has to refer to all the time. And with experience, they understand and they memorize certain loads because they know what they are, and they don't have to do that as much. And so you say, well, I never see them look at the load chart. Yeah, but if they start scratching their head, if there's something special they're picking up that's a little unusual, because they will have to do the load calculations first. When we're picking up a load with vertical slings, a pair of slings going straight up to, let's say, a spreader bar that the crane is holding, that's the simplest configuration, where you can literally have the load of whatever you're picking up just literally being picked up by those slings. That's not the same thing as picking up a load where you've got some slings that are going to a single master link on the crane. When you have two slings that are going from the load on an angle up together to a hook, those paired slings are pulling at an angle from each other, and that increases the tension on those slings dramatically. So the first thing is you have to have a center of gravity. So the center of gravity we abbreviate as CG or sometimes COG for center of gravity. But either way, that's the center of gravity of an object is the point around which the weight of the object is concentrated. And this could actually get the same behavior from a substitution from some point that was pulling at that point there. So when you go to pick up a load that's weird like this one, you might need to test out and try to figure out where the center of gravity is. So when you do that, you might pick the load a little bit off the ground and see how it dangles, how it's swinging, and then maybe drop it back down to do an adjustment for how you're picking up that load to determine its center of gravity manually. Engineers can figure it out for you too if it need to be. If it's complicated enough, you might need that. When this object hangs level, the center of gravity is vertically below the point from which the object is hung. So you always have to keep the center of gravity below the hook, as opposed to the side, but particularly not above it. Sometimes people will pick up a load like a crane. You pick up a crane with another crane, and they pick up by the frame, and that's dangerous because the load can fail so easily and tip over or roll over. So here we're looking at a scenario where I've got a ton of material. 2,000 pounds is the same as a ton. So let's look at this, 2,000 pounds. In a simple situation here, we've got a vertically paired set of slings pulling straight up. So you got 1,000 pounds on each sling, and they're magically supported here, but no, they're supposed to be connected to a sprayer bar, a beam that's being held by the crane or something. So there's just a simple 1,000 pounds of tension on each of those slings. Now let's look at the next scenario when the slings are connected to a master link at an angle of 60 degrees between them. So you look there on these two slings, they're connected together by a hook that's not showing up there, but they're connected to a hook picking up this 2,000 pounds. And so you've still got 1,000 pounds of the load of this thing on the slings, but you've got an additional 155 pounds of tension added because the two slings are trying to drag those two lifting handles toward each other. So if you had a fragile thing that you were picking up, you could possibly buckle the material. Maybe. But anyways, it's not too severe. It's only 155 pounds. It's something. It's 15% more load. So it's not nothing, but it's something. But, so that's one scenario. Look at this next scenario. We have 60-degree angle between these two slings here. Look at this next scenario here. That one, this third case, is where we got a 120-degree angle. Now, they had to use shorter slings to do this. But now the tension is much higher. You see that there's instead of 155 pounds of additional tension, they've got an additional 1,000 pounds. So there's actually 2,000 pounds of tension on each one of these slings. So that's a lot of force. There's literally 2,000 pounds of force trying to pull those two lifting handles toward each other, which, some lifting handles may not be strong enough for that, or the load might not be strong enough to take that stress, that compression. So the slings might not be strong enough. If you didn't keep that in mind, those slings might be breaking, or the hooks or something. So the rated capacity is really important to understand in relation to this tension. So this is part of the science of working with rigging, that people that get rigging training to figure out these rigging configurations have to study and learn about. Another extreme case I don't have here, but if you had one of these slings that was running just all it could do to reach from one lifting handle to another, and then you put a hook underneath that cable that's under tension and pick it up, you could have maybe 10 or 15,000 pounds of tension, depending on the scenario, just picking up this thing, which could be enough to break slings for sure. So this is a real issue here in safety. Now, so this is the phrase right here. I just popped up here at the bottom of the screen. I just popped it up. I forgot about it. As this, it's in boldface with a pair of red asterisks. As the sling angle between the two slings increases, the amount of tension on a pair of slings also increases. So as the sling angle increases, so does the tension on the slings. So that we're talking about that 120 degree angle on this page here. As you increase to 120 degrees from 60, you got a lot more tension. Okay, now we're looking at choking of slings. So look at the 12-foot member here on the right-hand side. We've got a sling running around, and then it's hooked with a shackle, and there's two of them. And so if you're picking up an object that's more than 12 feet long, then you always need a pair. Even long before you get to 12 feet, it's a good practice to have a pair of slings to control this load. But at 12 feet, you've got to start. The other thing is, over on the left-hand side of this page, I've got a not correct and a correct scenario here. You see on the incorrect side with the red slash running through it, the shackle is put in backwards where the screw pin can be unscrewed or tightened as it's cinching down on the pipe or the log or whatever you're picking up. That's incorrect. You have to put the bell of the shackle such that the sling is feeding through and sliding along the bell of the shackle instead of at the screw pin, because you could be loosening or actually over tightening that screw pin depending which way you're going. And that's either way, it's a dangerous situation. So there's a collection of numbers on this page. Over 12 feet long, you need 2 choker hitches together in a bridle configuration like this thing we have on the right-hand side. And then down the last bullet up here on the page, it says a choker hitch reduces the sling capacity by 25%. And so that means if this sling was capable of normally picking up a straight vertical hitch load of 10,000 pounds, it can only pick up 7,500 pounds when it's in a choker configuration, because that's a high tension point there. One other thing about chokers, and that's if you're lifting a bundle. So when you're lifting a bundle of materials, a bundle of wood, bundle of pipe, a bundle of rebar, reinforcing bar for concrete, you should be using a double wrap choker hitch where you wrap the sling around a full wrap and then you come back and choke it off. And that helps to compress the bundle evenly, like you see over there on the right-hand corner. That bundle is compressed evenly, and you're not going to have pieces of rebar flying out and shish kebabbing somebody. So a double wrap choker hitch is what this is. And again, if it's longer than 12 feet, you definitely need 2 of them in a bridle configuration, just like we had back here. So if you're picking up pipe of greatly different lengths, it's kind of the same issue here. You should be lifting those different lengths separately. So you separate them out into different piles to pick them up. Ensure that the open part of a hook, if you're using a hook, you got to make sure it's facing away from the center. When you got a configuration like this, where we've got a pair of slings and a bridle, if you had hooks, you want to point them away from each other so that they're less likely to unhook. What else here? Let's see. Oh, and then when you're picking up using carbon steel slings on stainless steel in particular, but even painted surfaces, you can cross-contaminate the materials, the metals particularly. And so it's a particular problem with messing with the stainless steel. We would use nylon synthetic slings, web slings instead on the stainless steel. So this comes up fairly often. We don't want to cross-contaminate by rubbing certain dissimilar metals where they touch each other and leave residue behind, and that causes oxidation and damage. When we're looking at pipe, there are tables that you can look up the weight of different wall thicknesses of pipe. And so that's what this table is here. And these are tables that you can use to figure out how heavy the load is. Never stand underneath any of these loads of pipe. Okay, that goes without saying about anything. Rigging valves are even more complicated because they are irregular shapes. So I'm talking about much bigger valves than something you'd have around the house. This is something big, like in the plants, where they can have valves for 24-inch pipe and they can be very heavy. So they require extra consideration and tag lines to keep them from spinning and rotating. And then here I've got a table of rebar, concrete reinforcing bars. Now the second column on the left lists the way we number bars in this country, and numbers where number 3 bar is 3/8 of an inch, number 5 bar is 5/8 of an inch, number 7 bar is 7/8, number 8 is 8/8. All the way down is that every number represents 1/8 of an inch in diameter. And way over on the left-hand side, you see how much it weighs in pounds per foot. So that you see that a number 5 bar weighs slightly more than a pound per foot. So that can help you when you're estimating costs, but it can also tell you something about the weight when you're trying to figure out how heavy this big bundle of rebar weighs. Figure out whether it's number 4 bar or number 5 bar and how many bars you have, how long the bars are. You can figure out how heavy that bundle is and whether you can pick it up or not. So that's an important thing. And of course, you use tags can help identify it, but you can measure rebar. From an arm's length, you can measure with your measuring tape and convert it to the numbers and that sort of thing. So with that, I have trade terms in here. I've got 3 pages of a glossary of terms that we've been using today in here. And so I've got this as a reference. And so here's the first page I've been kind of looking at. You can pause the video to look at it, or I'll have the presentation available in our class that you can go back to if you need to refer to them. And so there's another page dealing with jacks, material card, pallet jack, pipe mule. Remember, the pipe transport is just a large version of the pipe mule. Powered wheel buggy, roller skids. All these are all things I've talked about today on these 3 pages. And then at the end here, I've got kind of a review, kind of a summary of all of the things. Watch for protruding nails, wires, or sharp edges. Be sure to lift with your legs. Keep your back straight. Don't try to lift anything heavier than 50 pounds or longer than 10 feet. Remember, when you're stacking bags, cross-key them, really on every level. That means reversing orientation. Stacking bricks, well, taper the bricks back 2 inches for every foot above 4 feet. And with the masonry blocks, taper them back half a block or 1/2 block for every tier above 6 feet. And here, looking at the overall review on page 2 of this review, always put the heaviest loads at the bottom. What else? Moving a cart on an inclined or declined surface. Never load the cart beyond its labeled weight capacity. You'll lose control of it. Only use a jack to lift the load, not to support the load. You block up the load with cribbing before you ever try to go underneath it. Never stand under or place any part of your body under a load of a lifted jack. You got to block it up first before you get up underneath. Know the weight of the object to be handled. Know the capacity, the rated capacity of the handling device, and never exceed it. So these are things that I just talked about, but they're all summarized here at the end. Number 3, you must be trained, certified, and authorized. Remember that? And the next bullet, before using a concrete mule, which is called a Georgia buggy also, you thoroughly inspect the equipment, as you should for any equipment, really. Typically, when a freight elevator door closes, it could represent a pinch point in the middle as you're bringing the top and the bottom together. The second to the last one, the center of gravity, or CG, or COG sometimes, is the point around which the weight of the object is concentrated. The last bullet on this page, when the object hangs level, the CG, the center of gravity, is vertically below the point where the object is hung. So keep the CG below the hook. And the last page is summary here. With a bridle hitch configuration, as the sling angle between the 2 slings increases, the amount of tension on the pair of slings also increases. That was looking at those slings and that 2,000-pound load. And then when an item over 12 feet long is rigged, use 2 choker hitches or 2 hitches, depending on what you're doing, spaced far apart to provide the stability required to transport the load. And to lift a bundle of loose items or to maintain the load in a certain position during transport, a double wrap choker hitch should be used, or maybe 2 of them if it's over 12 feet. And the last thing on this list, if pipes of greatly different lengths must be lifted, lift each different length separately. And so here we are, finally, at the end of materials handling for a construction site.